Hi, let's solve the second problem from today's weekly contest, that is, check if it is possible to split array. So you are given an array nums of length n and an integer m, okay? So you need to determine if it is possible to split the array into n non-empty arrays by performing a series of steps, okay? So basically we are trying to divide the array into n non-empty arrays. Basically we are trying to divide the array in n subarrays where each subarray is going to contain only one element of the array. Now we have to do it performing a series of steps. Okay. Now what is this step that we are talking about? So in each step you can select the existing array which may be the result of the previous steps with the length of at least 2 and split it into two subarrays if for each resulting subarray at least one of the following holds, that is the length of the subarray is 1 or the sum of the elements of the subarray is greater than or equal to m, right? So either of these two condition is sufficed. Okay, so either the subarray that you are getting after splitting the array are of length 1, that is fine, but if they are not of length 1, then what should happen? The sum that you are going to get by adding the elements of that subarray should be greater than or equal to m. Now we need to return true if you can split the given array into n arrays, otherwise return false. Okay, so now let us go ahead and see this problem. So let me consider the very first case and let us try to understand what the problem is trying to tell us. Okay, and also let me write n here. Now we have this particular array here and the value of m is 4 here. So now I want to split this array into n parts. Okay, so now let's see how we can split it. So either I can split it from here or from here, right? So if I split it from here, I'm going to get 2 and 2, 1. That is, I'm going to get two subarrays after splitting it. So once I get these two subarrays, right? So this is the very first step. Now, if this step is valid or not, okay, it is being told to us that it should suffice any one of the conditions from that subarray length is 1 or like either of these two condition must be sufficed. Only then we consider this particular step a valid step. So otherwise, if the length is not 1, then subarray elements sum must be greater than equal to m, right? It is 4 here, but it should be greater than equal to m. All right, so either of these two condition must be sufficed. Only then it will be a valid split. Okay, so now after splitting from here, you can see that this is of length 1, that is fine, one of these condition is satisfied. But if you see this particular one here, the sum here the length is not 1, so this condition is will not be able to apply, but this condition we can. So let's see, 2 plus 1, right? So we have to calculate the sum. Is it greater than equal to 4? It is not. That means it is not a valid step. So this is not a valid split for this array, but we have another split, right? We have another split. What if I split from here? What will happen then? I will get 2, 2 and 1, right? So I'm going to get this. Now as soon as I get this, again this is perfectly fine because the subarray length is 1, but its length is not 1. So what should happen? The elements addition or the sum of the elements of this subarray must be greater than equal to m. So that is 2 plus 2 is should be greater than 4. So it is, right, it is equal to 4, but that is the condition. That means it was a valid split. So all right, so now we have two splits of this particular array, but what we need to do, we need to split it in n parts. Okay, so then I will take the, obviously I will take the bigger subarray and I will go ahead and split it. So I have this one. So there is only one possible split. So after this split, our array will become this. That is, we are going to get two subarrays, and because this particular condition is being applied, that means this was a valid split. Now you can see we have 1, 2 and 3 parts of this particular array. That means I will return true. That is, following this series of step, I was able to split my array into n parts, right? So that is what the question is asking us. Now let us go ahead and see how we are going to approach this problem, right? So if I see this problem, right, so what is the first thing that comes to my mind? Right, the first thing that comes to my mind is, what I will do is, I have 2 2 1 here. Okay, so what I'm going to do is, I'm going to make a split here. Okay, so I made a split here, and then the second split I'm going to make here. Right, so basically let me take a bigger array. So let's take another example here. 2 3 2 3. Okay, so it is 2 3 3 2 3. All right, and m is 6. Right, let us take this example. So what my intuition says is, either you clip the left element or either you clip the right element, and then you check out of both of these, right? That is, if I clip this element, then what would be of this particular subarray, or if I clip this element, then what will happen with this particular subarray, right? So my intuition says that what we will do is, we will clip either left or right element, and we'll check for the remaining subarray, right? Because see, that is going to be the, it is going to cover all the cases. Why? Because see, the split can be made here as well as here as well as here, but if you see, after making the split here, I will be getting this particular array. So it is including these splits, right? It is including all these 3 splits. So why do I need to, have 2 and, so this is first split. And then why do I need to include 2, 2, 3, and then I need to proceed, right? So I can do what? I can either clip this element or I can clip this element and I can move further, right? So this intuition lands me to a recursive solution, okay? It lands me to a recursion based solution. Why? Because see, what I will do is, for this particular subarray, if I consider, right, I have 2 here and I have 3 here, right? So first I will clip this 2 element and I will check for the remaining array if its sum is greater than equal to 6. That is awesome, right? So then I'm going to get this particular subarray. Now in this particular subarray, I have to again do the same thing, that is clip either the left element or the right element, right? And um, check for a valid split, right? And check for an answer. So doing this, what I will be doing is, I will go until I get 2 individual arrays with only 1 element in them, right? So here I can make a split, like if I remove this, I will get this, and here if I remove this, I'm going to get 3 3 and 2. Then I will calculate for this and calculate for this, right? So this is the idea behind my recursive solution, right? Now let us go ahead and see how we can implement this recursive solution, right? So for this particular array, right, I'm going to have 2 recursive calls, okay? So the 2 recursive calls will be after cutting the left element and after cutting the right element. Also notice one thing before we discuss the recursive solution, you might also say that why don't we take 2 pointers only, right? And by taking 2 pointers, what we will do is, we will take the minimum value out of the left and right, and we will clip the value which is minimum, right? And in that case we will be, arriving at a solution. But that is wrong, because in this array, if you try to do a dry run, you'll be able to see, right? So this 2 pointer kind of approach will not work here, right? So we have to check for all the possibilities, for all the kinds of splits, okay? So now let us go ahead and see the recursive based solution. So I'm going to write a recursion function here, and that recursion function is going to take my array nums. It's going to take a left pointer and a right pointer here, right? And here, so let's discuss the base cases. What is going to be the base case? The base case would be if I only have 1 element left in my array, right? Or if I have only 2 elements left in my array. That means if L equal R, in that case, so this will be a bool function. It will return true, right? And if L is equal R minus 1, that means I have 2 values inside of my subarray, then also I have to return true, because after splitting that, I'm going to get 2 subarrays with length 1, right? So our step condition is satisfied. Now after this, what I need to do, I need to make 2 recursive calls. That is, by clipping the left element and by clipping the right element. So if I clip the left element, what would happen? I have to make a recursive call to L plus 1 and R, right? That is the remaining array. And if I clip the right element, then the call becomes L2 R minus 1. But before that, what I need to do is I need to know whether or not this particular split is valid, right? Let's say the array that I'm getting here from this recursive call, right? Its sum is not greater than equal to m, right? This condition is not true for this particular subarray. So that means it is not a valid split. So we need to calculate the sum of this particular subarray, and then we can, after that only we can say that I have to make a recursive call to this, because this will be a valid split and I have to check what answer I'm going to get from here. Otherwise it will be false. Okay, so I am taking two values here, that is for answer left. So initially it will be false because we don't yet know if the split is going to be valid or not, and I'm going to take answer of right, and it will also be false initially. And after that, what I'm going to do is I'm going to sum up this value. Okay, so I am going to check if sum of, I'll have a sum function, so it will take my array, it will take these index, and it will tell me the sum from this particular index to this index, and I have to check if this sum is greater than m, right? Then I have to make a recursive call here, right? So I'll say recur in answer of it. So in ans of left, I'm going to make the recursive call, right? So after making the split, I need to check, right, what I'm going to get, true or false, right, for that particular subarray. So I will simply make a recursive call here. So I will say recur, and here I'm going to calculate nums and from L plus 1 to R. Okay, and after this, similarly, I'm going to check for the right value, right? And it is going to be nums and L R minus 1 greater than M. So this is the sum that we need to check. If this is valid, that means our answer of right is going to store the value for the right part. Okay, so it is going to be L comma R minus 1. After this, from this function, what we need to return? We need to return that out of this possibility and out of this possibility. That is, after we clip the left element and after we clip the right element, right? What am I going to get, right? So I need to return a possible answer, right? Let's say from left side, we are not able to divide our array into n parts, but from the right side I am able to. So I'll simply return ans left or ans right. So this is going to be my recursive solution, but this is brute force, right? This is a brute force solution, and the time complexity it is going to take is of big O of 10, right? So it is not a feasible solution. It will give us TLE, so we need to optimize it. So now if you see this particular solution, let me try to make a recursive tree for you here. So this is the array that we have, all right? And initially this is what we are going to pass, and the value we are going to pass is 0 here, and it is going to be 4. Okay, now what we are going to do, we will remove the left element and we will make a recursive call, because the sum of this will be valid, right? According to that we are going to. So if I do that, I'm going to get 3 3 2 3, and this is going to be, this is the first recursive call. The second recursive call would be clipping this element and making a recursive call for this part, right? So we are going to get 0 and 3 here. So this is how these two recursive calls will look like. Then I will do two recursive calls for this, right? So after clipping the left element, I'm going to get 3 2 3, right? So the sum is greater than equal to 6. That is perfectly fine. Then after this, because we have clipped the left element, so our left pointer will increase and it will be calculating for this value, all right? And then we will be clipping this particular value, so we'll get 3 3 2, again a perfectly valid split, right? This is a valid split, and this is going to be from 1 to 3. And after this, from here, what are we going to get? We are going to get 2 3 3 2, we will clip this element, we are going to get 3, 3, 2, and it will be from 1 to 3. And then here we are going to get 2, 3, 3, and it is going to be from 0 to 2. All right. Now you can see here we are calculating one thing twice, right? And similarly, if you go below down the tree, you will see more value which will be repeating. So we have overlapping sub problems here, so we can use DP solution here, right? So let us see how we can use a DP solution here, and using that DP solution, how can we calculate, right? So I'm gonna discuss the tabulation approach directly. So let's discuss about DP solution. All right, now see, inside of our recursive call, we can see that it is the two values L and R which are varying, right? So because there are two things that are varying, I need a two-dimensional DP array. So this is 2D DP problem. So I will take a 2D DP array. Okay. All right. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. All right. Okay, so this is what we are going to get. Now, what will, this is C, this is L, and this is going to be R. Now, what DPL and DPR denotes, right? So, from L to R, we are considering a subarray, right? The subarray from index L to index R. This is what we are considering. So DPL of R, basically it will be a bool array. Okay, so it basically tells us this particular subarray, can it be divided into the number of parts of its length. Okay, so let us say this subarray is of what length? It is of R minus L plus 1 length, right? So can I divide it into these many parts, that is individual parts? So this is what DPL of R is going to denote, right? For this subarray, if we can divide it into n parts, right? So that will be stored inside of this value. Now, what will be my final answer here? My final answer is going to be dp0 of n minus 1. Now, why? That is this particular element. So unlike traditional DP problems, we are not going to end up here. Why? Because see, what are we making inside of this DP array is this subarray. All right, so in the last, I want to know for the array that I have. So the array index starts from 0 to n minus 1. So the DP of 0 comma n minus 1 is going to store my final answer, right? So please understand this. Now I've arrived at this thing, that this is going to contain my final answer, and this is going to be my DP array, and what L comma R is going to represent. Now I need to know how am I going to fill it. Now see, if I go ahead and see my recursion, in my recursion, I have these two conditions, okay? This is R. So if L is equal R, then I need to return true. If L is equal R minus 1, or you can say L plus 1 is equal R, then we have to return true. So basically here, when L is equal R, I have to return true. So basically, my base condition says fill this diagonal, right? So these are the diagonal values. When L equal R, these are the diagonal values. I have to fill them as true. Then what is the next thing that I have to fill true, right? The next thing that I have to fill true is that L is equal R minus 1, or you can say L plus 1 is equal R. So basically I comma I plus 1, we are saying, right? L comma L plus 1. So R's value is L plus 1. So 0 comma 1, 1 comma 2, 2 comma 3, these values. So this particular diagonal value I have to fill, right? So here I have to fill true as well, right? So these are going to be my base condition from the recursion, I can see. So here in the tabulation approach, I will fill these. Now let us see how we are going to calculate these values and reach the final solution. Okay, so basically what I need to know is, in order to calculate this value, I need to know what if I clip the left element, right? So if I clip the left element, that means basically we want the answer from L plus 1 to R, and we are going to calculate from dp l plus 1 to r, and from dp l to r plus 1. This is what we want to calculate. Okay, so dp of l and r is going to be this, right? Out of these two values, right, I have to calculate, right? So similar to this, first we are going to calculate this sum, right? We are calculating the feasibility of that split, right? If it is a valid split or not, and then we will be calculating the answer as this. Okay, so what I'll be doing is I'll be having a OK function, right? So let me show you. Inside of my OK function, what I'll be doing is I'll be calculating the sum from index L and R, and I will be checking if that particular sum is greater than equal to M or not, to know whether or not I have made a valid split or not. Okay, so if I have a valid split, right, so basically I will check OK of L plus 1 and R, and I will do and with this TP value, and I will get some value. So let's say this is Ann's left value. Then I will be checking for OK, L comma R minus 1, and the next value, and this we will be storing in ans of right. So here you can see L plus 1 and R, right? So here if we are at, let's say I want to calculate dp of 0 comma 3. So what I need to know? I need to know dp of 1 comma 3, and I need to know the value of dp of 0 comma 2. So where is dp of 1 comma 3? dp of 1 comma 3 is this particular value. dp of 0 comma 2 is this particular value. So in order to calculate this value, that is dp of L comma R, I need this value and this value, right? So that is all I need, right? So I need these two values to calculate this value. Similarly, to calculate this value, I am going to need these two values, correct? And to calculate this value, I'm going to need these two values, right? So now I hope it is clear to you. Now let us see how we are going to traverse this and how we're going to calculate these values, right? So see, basically what we are going to have is, see, what we are doing is we started from L equal R. See, first of all, this thing we will never use. Okay, we are never going to use this lower half of our matrix. We will only be using the upper half, because obviously L has to be less than R or equal to R, right? Because L is the left index and R is the right index. So that is why this part of the array will not be used. Now, how we were moving? We were moving like this. L equal R. Then L equal R minus 1. So basically, if I see the difference between L and R, it is 0 here. Difference between L and R, it is 1 here. Then I'm saying to calculate this value, right? I need this value and this value. So here we are calculating first this diagonal, then this diagonal, and then this, right? So we are going diagonal wise like this. Okay, so first I need to fill this particular diagonal, then this diagonal, and then this value, right? So the way this diagonal is increasing is you have L, and the difference between your L index and R index is just increasing by 1. So before it was 0, then it was 1, then it is going to be 2, then it is going to be 3, and up to n minus 1 it is going to be, right? So this is the difference that you're going to have between the two indexes, correct? So we are going to have a loop here, right? So let's say gap. So gap will be telling us the gap between these two values. Now these two values we already considered because these are our base conditions, so we have already filled them. So our gap value will start from 2 and it will go up to n, right? And we will do gap plus plus. And after this, how are we supposed to calculate j, right? Here we are going to be iterating for I values, right? For I values. So I will have a loop here for I. So I's values will be starting from where? 0, right? So from 0 to 4 we have to keep filling the values. Okay, so from I is equal to 0 comma, now here you have to put this condition, right? Because you are treating this gap as well, right? And the jth index is actually, see, I is your L, right? I'm considering I is L. So R is what? R is simply L plus this gap value, right? So this gap value shouldn't exceed n, right? And then I will do I plus plus, and then here I'm going to calculate j, and j will be equal to I plus gap, and then I will be filling this particular diagonal. Okay, now let us go ahead and see. how we have implemented it. So here I have taken the size of the vector, and here I have declared my dp vector. Okay, and here I have already explained you what this OK function is, right? It is just telling me the feasibility of that split that I'm making, right? If it is a valid split or not. If it is a valid, it will tell me, okay, this bool OK function. And after this, here I am iterating. Okay, so I'm iterating from a gap value, right, which I already explained you. So we are increasing the gap between L and R pointer, right? And we are filling our matrix diagonal wise. So then we are iterating for the L value, right? So this is the left pointer's value, and this is how we calculate the right pointer, right? So this is the difference between, gap is the difference between left and right pointers. And after this, again, just similar to my recursive solution, I am calculating an answer left and answer right. So here, how am I calculating it? See, I'm going to know up to dp of I to j minus 1, what is the value? Up to dp of I plus 1 to j, what is the value? And then I will also be checking here that whether or not that particular split that I'm making is valid or not. Okay, so that this OK function is going to tell me. So if this particular split is valid, then whatever values is stored at dp, I'm going to take it, right? And I'm going to put and here, right? If it is false, then that means I cannot, split my array into n parts, right? If dp of I to j minus 1 is false. Similarly here, so that is why I'm using and operators. So using and operators, I'm getting to know, okay, whether or not up to this point, right? Up to this point, I was able to split my array or not, right? So if I was after splitting left part and after splitting right part, this is what this dp of I comma j minus 1 and I plus 1 j is representing, right? So if they are false, then my answer left is going to contain false only. Then dp of ij is going to be an OR operation between a left answer or a right answer, right? So we saw that we have two possibilities, either clipping the left element or the right element, right? So it might be the case that by clipping the left element, I'm not going to get any answer, right? But clipping the right element, I'm going to get an answer. So I have to put an or operator here, right? So because these are two possibilities, and out of them, anyone can be possible, and if any one of them is possible, I have to return true. And in the end, we already saw that our answer is going to be contained from 0 to n minus 1. So that is what we have returned. So from 0 to n minus 1, that is my original array. I have returned the answer, which is stored in my dp array. So I hope you have understood the solution. Now the time complexity of the solution would be, here it is going from n, right? So this is running n times, this is also running n times. And again, because we are using this OK function here, so in the worst case, it can run for n times only. So that means the time complexity becomes big O of n cube. If you want, you can, remove this OK function while attempting in context. I did not remove it. So you can have a sum array, right? A prefix sum array. And from that array, see, all that we are doing is we are clipping either the left element or the right element. So have a prefix sum array and clip the left element or the right element. You can, according to your comfortability, you can have a prefix and suffix array both, or you can even have a 2D array for calculating sum, right? So to give you the sum from I to j minus 1 directly, right? So yeah, for this solution, the time complexity is big of n cube, and space complexity, as you can see here, we are using this 2D matrix. So the space complexity is big of n square.